The fastest way to build a dangerous Salesforce AI system is to treat it like a prompt problem instead of an architecture problem. Prompts matter, but prompts are not your security model. They're not your governance model. They're not your rollback strategy. They're not your audit trail, and they're definitely not your production architecture. I'm Robert Wieland, a Salesforce architect focused on AI, automation, and enterprise systems that actually survive production. This is Intentional Architecture. Today, we're talking about how to build Salesforce AI that can survive contact with the real world. Not just the demo, not just the sandbox, but production. Right now, a lot of the AI conversations still orbit around prompt engineering. What prompt should we use? How do we get a better answer? How do we make the output sound more polished? How do we stop the model from hallucinating? Those are all useful questions, but they are not enough, because in an enterprise system, the problem is not just whether the AI gives a good answer. The problem is what the AI can see, what it can do, what business logic it can trigger, what systems it can touch, and what happens when it is wrong. That is especially true in Salesforce, because Salesforce is not just a database. It is not just a CRM screen. It is not just a place where sales reps update opportunities. Salesforce is often connected to pricing, approvals, service workflows, customer data, contracts, health information, financial processes, marketing journeys, integrations, automations, and external systems. So when we introduce AI into that environment, we're not just adding a smarter search box, we're adding a new actor into the business process. And that actor needs architecture. Here's the question I think every Salesforce team should be asking. Not how do we write a better prompt, but what system of boundaries, permissions, logic, review, monitoring, and recovery makes this AI safe enough to participate in production? That is the shift. Prompt engineering is about getting the model to respond well. Architecture is about designing the environment where the model can operate safely. That means we need to move from prompt-first thinking to architecture-first thinking, because a clever prompt can make a demo look impressive, but architecture is what keeps a production system from becoming a very confident accident machine. Technical term, extremely official. So here's the framework I would use for Salesforce AI that survives production. 6 questions. Context. What data can the agent see? Authority. What can the agent do? Determinism. What must follow exact business logic? Human review. When does a person step in? Observability. How do we know what happened? Recovery. How do we roll back or correct mistakes? That is the model. Context, authority, determinism, human review, observability, recovery. If you get those 6 wrong, the prompt will not save you. If you get those 6 right, the prompt becomes part of a governed system instead of a magic spell you hope keeps working. As a general architectural principle, hope is not control. Let's start with context. In AI systems, context is power. The better the context, the more useful the agent can be. But the broader the context, the more risk you introduce. In Salesforce, context might include account data, contacts, opportunities, cases, contracts, entitlements, notes, emails, files, call transcripts, order history, product data, marketing interactions, or external data from integrated systems. So the question is not just, can the AI answer the question? The question is, what information did we give it in order to answer the question? That matters because context is where data leakage can happen. Maybe the agent should know the customer's support history, but not their financial details. Maybe it should know the opportunity stage, but not confidential pricing notes. Maybe it should summarize a case, but not include restricted fields. Maybe it should retrieve knowledge articles, but not expose internal-only documentation to a customer-facing agent. This is where architecture matters. You need data classification. You need permission-aware retrieval. You need field-level security. You need sharing enforcement. You need clear rules about what context is allowed to enter the prompt or retrieval layer. Salesforce's Einstein Trust Layer provides important platform guardrails, including secure data retrieval, dynamic grounding, auditability, toxicity detection, and zero data retention with supported LLM providers. But it does not remove the architect's responsibility to decide what data the agent can access, what sources are grounded, what fields are exposed, and what should never enter the agent context in the first place. And for Agentforce specifically, you still need to understand which trust layer protections apply to your use case. Not every protection behaves the same way across every AI feature. The trust layer is a guardrail. It's not a substitute for intentional data design, because once sensitive data enters the AI context, you have to assume that it can influence the output. Context is not just input. Context is exposure. The second question is authority. What can the agent actually do? This is where the risk level changes significantly. An AI that can summarize a case is useful. An AI that can update the case is more powerful. An AI that can close the case, issue a refund, update an entitlement, change a quote, send an email, or invoke an external API is in a completely different category. At that point, you're no longer designing a helpful assistant. You are designing an actor in a business process. So authority needs to be explicit. What tools can the agent call? What APIs can it access? What flows can it invoke? What records can it update? What fields can it change? What external systems can it touch? What transactions require confirmation? What actions are read-only? What actions are reversible? What actions are blocked entirely? This is one of the places where teams can get lulled into danger by a good demo, because the demo usually shows the happy path. The agent understands the questions. It finds the record. It performs the correct action, and everybody claps. Someone says transformational. A LinkedIn post is born. But production is not the happy path. Production is ambiguous requests, missing data, duplicate records, edge cases, permission conflicts, and humans asking for things in deeply creative ways. So authority cannot be vague. The agent should not have a broad power because we trust the model. The agent should have narrow, intentional authority because we trust the architecture. The third question is determinism. What parts of the process must follow exact business logic? This is where we have to be clear about what AI is good at and what it should not own by itself. AI can be excellent at summarization, classification, drafting, routing suggestions, explaining options, identifying patterns, and helping users navigate complex information. But enterprise decisions often need deterministic logic. Pricing rules, approval thresholds, eligibility checks, compliance requirements, data access rules, refund policies, contract terms, medical or financial workflows, regulated decisions. Those cannot just be vibes. And yes, vibe-based compliance is probably not going to pass audit. The architecture question is, where can the agent reason and where must the system enforce exact rules? A good pattern is to let AI assist with interpretation and recommendation, but keep critical decisions inside deterministic services, such as Salesforce Flow, Apex, validation rules, approval processes, entitlement logic, or governed APIs. The AI can say, based on the case notes, this looks like a high priority escalation. But the system should still enforce what qualifies as high priority, who can escalate it, what fields are required, which queue receives it, whether the customer is entitled to that level of service, and whether a human must approve the action. Reasoning is useful, but reasoning needs rails, and those rails are designed by architects, admins, developers, security teams, and business stakeholders, not by a clever prompt alone. The fourth question is human review. When does a person step in? This matters because not every AI action should be fully autonomous. Some actions can be automatic. Some should require confirmation. Some should require approval. Some should only produce a recommendation. And some should not be handled by AI at all. That distinction needs to be designed. An agent might be allowed to summarize a customer issue automatically. It might be allowed to draft a response, but require a human to send it. It might be allowed to recommend a refund, but require manager approval above a certain amount. It might be allowed to route a case, but escalate to a human if confidence is low or customer impact is high. Human in the loop should not be treated as a vague safety blanket. It should be a specific architectural control. When does review happen? Before the action? After the recommendation? Only above a threshold? Only for regulated data? Only when customer impact is high? And just as important, who is the human? A support rep? A manager? A compliance reviewer? A business process owner? Human review sounds simple until you have to define who, when, why, and what they are reviewing. That is architecture. The fifth question is observability. How do we know what happened? This is one of the biggest differences between a cool AI demo and a production AI system. In a demo, the agent either works or it does not. In production, you need to know what happened across time. Before the action, what did the user ask? What context was retrieved? What records were included? What instruction version was active? Then during the action, what tool did the agent call? What decision did it make? Was there a human approval? And then after the action, what data changed? Did the workflow complete? Did an integration fail? Was the output later corrected? Salesforce's custom scoring evals announced around TDX are a step in this direction. They let teams define what good looks like for a specific agent use case and score responses against those criteria. That is useful, but it is not the whole observability story. Architects still have to define the evaluation criteria, connect the feedback loops, and act on what they learn. If you cannot trace what happened and why, you do not have production observability. You have a black box with a friendly interface, and friendly black boxes are still black boxes. For Salesforce teams, some of this may come from native audit and event tooling. Some of it may need to be designed as part of the agent implementation itself. That might include event logs, custom logging objects, platform events, audit trails, monitoring dashboards, integration logs, and structured feedback loops. The goal is not to log everything forever. The goal is to log the right things so that when something goes wrong, you can reconstruct the chain of events. Because in production, the AI did something weird is not an incident report. It's the beginning of one. The sixth question is recovery. Prevention gets the most attention. Recovery gets the most incidents. Because mature systems assume that something will eventually go wrong. An agent will misunderstand a request. A prompt change will produce worse behavior. A tool will be too permissive. A retrieval source will include bad data. A business rule will be incomplete. Or an integration will fail halfway through. A human will have to approve something they should not have approved. That is not pessimism, that is production experience. So the architecture needs recovery paths. Can we disable an agent quickly? Can we turn off a specific tool? Can we roll back an instruction or agent version? Can we reverse a record update? Can we identify all records affected by a bad decision? Can we notify impacted users? Can we route exceptions to a human queue? Can we replay a failed transaction? Or at a minimum, can we identify exactly where it broke? Can we correct the prompts, permissions, retrieval sources, or business rules based on what we learned? This is also why I think in terms of blast radius. If the AI gets something wrong, how far can the damage spread before a control catches it? A production-ready Salesforce AI architecture should limit blast radius, not because we expect failure all the time, but because responsible systems are designed with failure in mind. And recovery without accountability is just cleanup. Someone has to own what the agent did, not just who built it, but who is responsible for what it does in production. So let's bring it back. If you are building Salesforce AI for production, do not start with what is the perfect prompt. Start with context. What data can the agent see? Authority. What can it do? Determinism. What logic must be exact? Human review. When does a person step in? Observability. How do we know what happened? Recovery. How do we fix it when something goes wrong? That is the architecture conversation. And when you frame it that way, AI stops being a magic feature you bolt onto Salesforce. It becomes part of an enterprise operating model. That is the difference between a demo and a system. A demo asks, did the AI respond impressively? A production architecture asks, can the system act safely, explainably, and recoverably inside the business? That second question is where architects earn their keep. The future of Salesforce AI is not just prompts. It is governed action. Humans, agents, data, automation, integrations, and business rules all operating inside intentional boundaries. And if you want to go deeper on how Salesforce has formalized the process of building and governing agents, there is a structured lifecycle for that. That is the next conversation. Prompt less, architect more. That is intentional architecture. If this was useful, subscribe, and I'll see you in the next one.